So now this is it. We'll start making a production model. Excitement. Yeah, it is exciting because it's how we're going to get stuff out of ZBrush and actually be able to render it or put it in a game or whatever you want to do with it. So, a lot of stuff. We have to retopologize it, which is typically something that could be quite, could take some time. If you want a really perfect production mesh, like a really nice animation-friendly topology. But I'm going to leave that up to you. So I'm not strict at all in terms of the requirements for that. So if you want, if you're fine with what you get from the C remesher, which is pretty good now. I mean, the C remesher is good. Okay, but it might not be typically in a production for a hero asset. You'd probably go in and retopologize manually still, just to get it perfect. But I'm not, I'm not telling you you have to do that. The thing here is just to understand how this works, so that you can take the Dynamesh, make some sort of retopologizing for it. So it needs to have more or less animation-friendly topology, which just means, in general, it means circular topology around the eyes and circular topology around the mouth. So if we search for, if you do some reference search again, so we could do like facial anatomy. Google is our friend, as always. So we're trying to recreate what the facial musculature is actually doing. So if you don't have these kind of radial topology, it's going to be very difficult to make deformations that kind of look pleasing for facial gestures. So that's the whole point. And also, if you just do some research into, which I encourage all of you to do, look at some topology. So you could do maybe facial topology for animation. You'd find a lot of kind of difficult, different references. So here you see basically radial topology around the eye sockets, radial topology around the mouth, and then a lot of people also like having a line here along the nasolabial fold, which we kind of talked about earlier. Like this folds over, you get the general picture. So if you can also, what I think you should see is that a lot of these meshes, they're not very, very high poly. So that's another important thing here, is not to think that you have to make, because I think most people do that when you start out and you retopologize something for the first time. Say, okay, I'm going to make this perfect topology, and then you start out with too many points. No, you don't have to do that. Keep it fairly low, and then that's typically a better approach. Because the final mesh to be rigged shouldn't be too dense. So it's always this kind of not very concrete defined number. It will vary, but typically not too dense. So I think the best thing is to do what I'm doing right now, is just to look at some references. So I'd say something along the lines of this is looking pretty good in terms of density. This is not too dense. Something like this. This is looking very dense, but this is, first you would retopologize it, and then you could subdivide it, obviously, to get a higher density. But while you're retopologizing your first iteration, probably you'd be better off keeping it a little lower. So anyways, you can see this over and over again in a lot of these references. The whole point is radial topology here, radial topology here, and then also you like defining the nasolabial fold. Right. So it's not, the automatic algorithm in ZBrush, the C remesher, it's not, it doesn't really, it doesn't take this into account. It just looks at the curvature of the mesh, but being that it does a pretty good job with it. Okay. And then depending on, yeah, if you want to, even if you're in VFX or if you're in games, I'm not really, if you want to make a mesh with a normal map, that's okay, because you could, normal maps could still be used for animation or for animation projects. You don't have to do displacement maps. It could also be if you want to do like a VR movie, these days, to me, it doesn't really matter. These two worlds are the same. So if you want to make a final production model and you want to bake out normal maps, okay. Or if you want to do like high-end VFX and you want to do 32-bit EXR displacement maps, that's really the way to go if you want to do high-end VFX though, because that's actually going to make it look in the render, like in the final render, it's going to look exactly like it does in ZBrush. Like if you set it up correctly, it will actually displace the mesh at render time, and it should look just like your mesh in ZBrush. So that's pretty cool. The normal map, of course, is a huge, it does a good job, but it will only look good. Like it doesn't actually displace anything, right? It just looks like, it just bends the normals around on the polys, and it looks great. It's a wonderful trick, but it doesn't displace the surface. So if you look at the contours, it will still be flat. Okay. So how many of you have tried like baking normal maps? Yay. Good for you. Well, good. Okay, great. So we'll talk about that. Yep. And then blah blah blah. Yeah. Let's just, I think we started. So let's see if I had a. So now we're kind of in the territory where uh, most likely you will run into some hiccups and things, and you have to figure things out, and there's a lot of engineering. Now you need to put your engineering hat on. The artist hat, take that off, because now it's more technical. It will be more technical. You just have to embrace the process. Anyways, so just to say that you probably will have to, some weird things will happen during this process. You just have to, yeah, stay with it. The whole, like, I encourage all of you to first do just the head bust retopologizing, and that's the mandatory assignment. And then the optional one, doing the full body, which was originally also mandatory. But I think it's much better that we're making that optional, but because it will require more work, obviously. So you have a lot of meshes, but it's the same process. You just expand it. Anyways, so this was the sculpt that I did for a previous lecture. So let me turn this into a bust. So we're just gonna use this top part. I'm just gonna mask that out like that. Maybe invert the mask, and then down here we can go split mask points. So that's gonna turn it into two subtools. Now we're left with that. There's gonna be a hole at the bottom, and then we can go reconfigure the Dynamesh. And there we go. So now we have the mesh. So this is okay. So granted, I would have taken this further. We don't have a lot in terms of tertiary details, but I can retopologize it at this stage, right? The tertiary details, if you think about it, they're going to be very tiny details on the surface, like skin pores or wrinkles or anything like that. We don't need the Dynamesh for that, right? Because the Dynamesh is just to reconfigure so that you can do anything. You can make large changes, recompute. So I can just easily retopologize at this stage. Let me actually save this project. So just going to save it locally. So CGArt. So then Shift F, I can show the wireframe. So the wireframe of the Dynamesh doesn't make any sense in terms of topology. It really just creates these very straight, not very pretty polys. You know, that's just the nature of the Dynamesh. That's how it works. So we've tried this. Let me just duplicate the mesh so we have a copy of it. And then we've tried this before, but let's just run the C-remesher algorithm, see what we get. So under geometry C-remesher, this is just gonna generate a new topology for it. If you hold Control, we can get, so this, you see, this slider value in thousands. So if it's set to 5, which is initially, it's gonna have approximately 5,000 polys. Let's just, you gotta run it and see what it does. It's very quick. So how many of you have actually tried retopologizing in Maya or somewhere else? Like 3, okay. Yeah. It's a lot of work, right? So being able to do this on the fly, I mean, this is, okay, Shift F. This topology is really great. I mean, for what it does in a few seconds. And if you're doing a render, I mean, this is more than, you wouldn't have to do this, but why not? And if you're doing a simple, also in production, this is used, and if you don't have like a hero character, you can get away with this. Because it does give you, as we see, you have radial topology, more or less, around the eyes. So, but it doesn't really understand much. You would have to go in, but you see, it's pretty good. It's pretty good. It's much better than it was. It's definitely following the curvature, right, of the musculature and following the curvature of the shapes. So this is going to make for much more credible deformations. So even in the sculpting process, sometimes I like to do this. Like when I'm done with the rough secondary stage, I would just like retopologize it, because then when I make brush strokes, it's just going to follow this topology a lot nicer. And also if I'm moving things around, you see, it's just, it creates for more, it's just nicer to work with, because just the way the polys are flowing. So, and then also there's I'm just mentioning all this for you to experiment with, because now, again, this isn't really not like a clear-cut fix all solutions. There will be experimentation on your part, because depending on the mesh, no one knows what the C-remesher is going to give you. You're just going to have to try. But then also there's the C-remesher guide curves. So if you go to B, Z, and C remesh, this brush allows you to draw curves. So again, some people say, well, you add more, it's preferable. If you add just a few, that's better. Just try it. And then, but I wouldn't, like, personally, I don't think you have to do too many. You just have to sort of let it know that you want radial topology around here. Whoops. Maybe. Oh, that's a bit sloppy, but let's just try it. And then do that. And then if we wanted to, we could say, okay, and then I want like an edge flow going this way, and then I also want a curve following that nasolabial fold. Something like that. And then, okay, let's try it. So C-remesher. And also there's a way to use polypaint. So that's more for if you're doing a full body. And then you probably want the face, you want a little bit more poly count, a little bit more high definition in the face, but for the body, you want less. So then you can use polypaint. You can hold Control and see what it does. Pure red means a higher polygon density. So if you paint with red color, a poly paint on the face, and then yeah, you see what it does. So I think you can also use yeah. So it also takes into account the opacity of the color. It's pretty. It's a really great tool. I mean, it's very powerful. If you paint with red color, depending on the opacity of the color, it will actually make more or less density in terms of poly count. So that's very powerful. Did it actually? Yeah, so there's definitely more radial topology around here. See, it did that. It's quite successful. And so this is how you have to go in here and analyze it and see if you're happy with it. You know. But let's say, oh, yeah. Let me actually, I need to open the previous project because it got rid of my Dynamesh there. Or not, we can just use it. Okay, we can use this. Let's say I'm happy with this. So this would be the basis for, this would be it in terms of the poly count or the topology. So now we have to make UVs for it. I can, so you can do that in headers, you can take it in the headers. I will show you how to set up UDIMs today. For those of you who want to be doing VFX rendering, if you're doing it in game, typically you would have things more aligned in one UV layout. So let's first try, we can actually UV map it in ZBrush itself. But let me export this mesh right now. So this would be CGArt2. So didn't I just? Oh, I just saved the ZBrush project. Didn't make a folder. Make a folder for it. Let me just try to stay a little organized. So you will have a lot of files floating around. So at the very least, having it in one folder probably makes sense. Should be. So put this in there. Okay, and then just gonna export this OBJ. So CG, yeah, and this would be, yeah, just bust retopo. And we can see, again, just apply our own judgment and see that, okay, it's fairly low res, right? It's not like super high in terms of poly count. So UVs for it, we can, like I just exported the OBJ. This is also, you just have to start getting comfortable, like going between different softwares and just exporting OBJs, going back into ZBrush. You can at any time reproject details back down onto to an OBJ in ZBrush. This will become more clear. But anyway, so here's the OBJ, and I could have UV mapped it in headers, for instance, if I want to make more UDIMs. But let's quickly just make UVs for it inside of ZBrush here. So we have in ZBrush we can do we have under C plugin the UV master, which is also pretty great. It will adhere to polygroups. So if you polygroups, maybe you've noticed this, but if you press Shift F, sometimes you'll have different colors on the mesh. That's ZBrush has a way of grouping a single mesh into polygroups. And it serves various purposes, like in modeling also, like if you're doing more hard surface things, there's a lot of things, interesting things you can do with groups. But also, if you're UV mapping, you can make use of polygroups to UV map, have more control over it in ZBrush. I'm not going to do that now, but I just want to group visible so that everything is just um, one poly group. And then I just go up to UV master, and it's a symmetrical. Um, it just want a symmetrical layout. Blah blah blah. Okay, and also here you can do control painting. So you can make. I think it. Let me see. Well, that didn't give us any information. But you can, I think you can use red. I think you can also use blue, and that will do the same thing. Like it will give you more or less uh, texel density or resolution in that area. So it's also a very powerful feature. So there's a lot of these powerful features in ZBrush. But here we can unwrap. So now it's unwrapping. Wait a minute. Poly group 1 of 7. I just group visible. That's mysterious. An error occurred. Okay. So for some reason it's confused. Maybe it's because it was actually hidden. I don't know. Let's try again. So if I go down to polygroups, it should group visible. So auto groups, group visible. It should group only this. Let's try again. Unwrap. No, it's doing the same. Unwrapping poly group 1 of 7. It's a bit mysterious. Huh. I'm not sure what's going on. Let me try to, yeah, I'll just initialize and then just try to import the bust again. Still doing it. Try to. I'm gonna throw this OBJ in Maya. See what happens. Yeah, so it is recognizing it as groups. Well, I guess I can mask the whole thing and then group masked. Hopefully. Nope. All right, not sure why it's still recognizing groups there when it doesn't have groups. I probably just don't know what I'm doing here, but symmetry group split. No, mesh is composed of only one group. So it doesn't have groups. Let's see. Okay. I seem to do it. So, all right. So, not sure why that didn't really make sense. But anyways, in the tool, you can see that you have a tab here called UV map. You can delete UVs, which means gets rid of the UVs. So it seemed to have some UVs in there, so I deleted UVs, and then I made sure there were no poly groups. So I masked everything, and then I said group masked. And it has only one poly group. And then I could run the UV master and just an unwrap. And down here under UV map, there's a button for morph to UV. That's just going to morph it, and it's going to show you what it looks like when it's flattened. It's kind of magical. So that's it. So hopefully that's fine. Let me just retype and UV. So that's it. And then, like, if we had some, let's say we had some more details in the original bust. Let me open the previous project because I saved it. No. We could. Oh yeah. So here we go. So this was the So there's the bust right before I retopologized it. You can see that there's some information there. Like it's looking more detailed than our retopologized mesh. But now we can just project whatever we had in the Dynamesh back down to the newly retopologized mesh. So if I now go, let me just temporarily switch the tool to the simple brush. Yeah, just switch it. You can see this one is still here, but I just currently switched. So now I can import the bust retopo UV. Now that's in there. Control N, clear the canvas. And then, where was I? Is it this one? Whoops. Right. So that was the version before and then I can go subtool and append. And now I can append the newly imported bust retopo UV. Now that's being appended in here as a subtool. And then I can move it up in the subtool palette. So now that's just right underneath the Dynamesh bust, right? Let me just get rid of all these other pieces because don't need it for now. Because we're just doing the bust. Whoops. Okay. A lot of issues. It seems like for some reason when I exported the OBJ, it's not adhering to the size of the thing. Which it should do, which it didn't. So, I mean, we could manually place it in there and bake whatever information we had down here to the new one. I hope that's clear. But let me not spend time doing that. Let me rather just duplicate this, and on the duplicate, I'll just subdivide it. Control D, Control D. And let me just, I mean, I'm not gonna, don't really have the time to sculpt, but let me just do some crazy things. Let me just add something here. So you can imagine, like, if this were what you had in the Dynamesh that you lost when you, let's do something. Let's add some alphas or something. So it looks like something. Control D, just add some scales to him. So we have something there. So let's say you had some details in your Dynamesh and you lost it right when you did the retopologizing, of course, because the retopologizing is going to make the mesh much lower in terms of poly count. I'm just dragging a lot of that stuff on there. Let's change to alpha just to get some quick something there. Some tertiary details. Okay, so this is what you had in the original Dynamesh, and you put that on top of the newly retopologized mesh. So if I hide this one, so this is the retopologized mesh. Before I project it, obviously, I have to subdivide the retopologized mesh so it has enough polys to retain that information. So I go Control D, subdivide, Control D, Control D. So maybe 700,000. should be enough. Just right under 1,000,000 polys. And then I want to select the one I will be projecting to, should be the one that's currently selected. And then I also just make it so that the top one is visible, like just enabling the icon there. And then I can go down, project all. So this is a very liberating feature because it means that you can actually project anything down to anything. So if you have a mesh and you have a more high resolution mesh, it doesn't matter what the UVs look like or anything. As long as you have place one on top of the other, hit project all, ZBrush is going to try to project all of that detail down to the bottom mesh. And there it did so. So if we compare that to the top one, whoops, that's the bottom one. It's just that. So it means that this is how you can take any sort of Dynamesh sculpt or anything, bake it down to the mesh that now has a different topology, different UVs. You know, that's all. That's the whole thing. That's what we're doing. Because now, all of a sudden, we have a mesh looking like the high def one, but I can also hit Shift D and go down and rest. So now this is not a Dynamesh. Okay, now we definitely don't want to be in Dynamesh at all. So you can see that Dynamesh is disabled. If I click Dynamesh and reconfigure the Dynamesh, I'm going to ruin everything I did because then I'm just going to get crazy topology. I don't want that. Now we're in a different world. Now we have actual subdivisions. So if I hit D, that's the hotkey to go up in subdivisions. And I can see at the higher level of subdivisions, at the 700,000 level, with polys, we can see the details. If I hit Shift D to go down res, I'm down to the bottom one, which has the animation topology, right? And so this is what we need. You need the high-res version and the low-res version with the beautiful topology. And since we have both of these in here now in ZBrush, we can go to multi-map exporter and actually make ZBrush bake out a normal map straight from here. So it's just going to analyze the high poly mesh, bake it down into a normal map. So you remember what a normal map is? For those of you who haven't tried it. What's a normal map? Let's search for it. It's a funny looking map. It's like a bump map, but it actually bends the normal of the polygon in a given direction according to this color information. So it's just this brilliant way of tricking the renderer. It will look like that surface detail is there because it's bending the surface normal, like it's bending the way the light is reflecting without there being geometry there. So it's just incredibly ingenious way of doing this. So that's why normal maps are used so much in games, because they're incredibly quick to get that real-time render. But also for film. But of course, the limitation with it is that you cannot, it will not actually displace the surface. For that, you'd need, oh, look at this, this is beautiful. For that, you would need a displacement map. This is a normal map. Let's just save this one, see what it does. So, normal map. I'm just going to throw it on there. Go into Maya. Make a plane. Oops. Yep. And let's just make a blend. Bump mapping. So Why is it not responding? Things are not working today. Let's go to the hypershade. Come on. Oh, I made more blends and things. Let's just delete unused nodes. There's my blend, graph input connections. So see, nothing's going into the blend currently, but then I can go to bump. Oh, it's not responding. Okay. Well, let's make it manually. So I can do, I need to do a file node. And you shouldn't have to do this manually though. Then we need a bump node. Let me try to search for it. Bump. Yep. And then the out color of this is the bump value. Or I guess not. Am I not doing it right? Let's see. Bump 2D. Out alpha. So that works. Okay. This has never happened to me before. It's not. Let me restart. New bugs keep appearing. It's okay. I just want to show you what a normal map would do. Let's try again. Create. Give it some time to boot up. Plane. Okay. Create a blend. Bump mapping. Okay. That's very odd. Does this happen to any one of you? Like when you try to attach something? It's never happened to me before. I don't know why this is. Right, yeah. Drop it onto the, yeah, yeah, good idea. So, yeah, so it's, there we go. And we need to set the, yeah, so we can drop that onto the attribute. That would work. Let me try to dock the attribute editor. Gosh. No. Go away. Huh. Okay, let's try to drop the file node onto bump map node. Yes, perfect. Oh yeah, so it does go from out alpha. Okay, fine. All right, so in the bump node, you would set it to tangent space normals. So most of the normal maps you'll find they're actually in the tangent space normals. And let's try it. Well, I think we just have it there. So let's see. Blend, graph input connections. So there you'll see that's the chain that we need. Now it's going into normal camera. This is the bump node. It's set to tangent space normals. Oh, and also actually using the viewport 2.0, I think we need to set this file node and color space raw. Yeah. Okay, let's see if that worked. Press number 6. There we go. Control space to go full screen. So that's the illusion of the normal map. So you can see that. Let's add a light source. Do a directional light. Press number 7. So the normals obviously react to the light source. I can't rotate that thing. Okay, there we go. Yep. So it appears as if that detail is there because it's just bending the normals. But of course, it's only an illusion. It's only there on the surface, but it looks good, like from here. You know, depending on the light, where the light is coming from. That's all driven by a simple little map. But if I go here and look at the side, whoops, kind of breaks the illusion because it's just flat. But it really works for surface detail. So that you can see the normal map. This is a tangent space normal map, and all of, like most of the ones you'll see, if you just try them, download one and then just apply it and try. But let's then try to bake out this normal map. I'll guess, yeah, it'll be pretty quick to do here. So multi-map exporter, we can select normal map. Map size obviously tells you the resolution. It's going to be 2K. Maybe 2K or 4K would be good for this. I'm going to do 4K. It's going to flip it vertically on export, and that's something you want to do for all the maps. This is the general export options. Flip vertical is what you want because the UVs are, as you know, they're like upside down in ZBrush. Yeah, as you would have it in RenderMan, but most other renderers don't. So we need to flip it, and then tangent space normals, smooth normals. Okay, let's just try it. And this is another one of these things that, yes, there will be some errors. You will find that, oh no, the bake didn't go well. I have to bake again. Okay, especially in ZBrush. It's not particularly good at baking. Okay, so there are other, like XNormal is very, very good. It's a great application, which unfortunately we don't have on the lab. And they had some sort of security concerns with installing it. I don't know why. Sometimes these things happen. So we don't have XNormal, but if you ever try XNormal, it's a great baking application. So all you need, like I said, you need the low poly version, and then you need the high poly version. As long as you have those two meshes, you can bake it anywhere. You can bake it in Maya. There's also a normal map bake operation in Maya. We can take a look at that. You can bake it in XNormal. You can bake it in ZBrush. The thing also, though, to take note is that depending on the final destination for the normal map, and this makes things even more complicated, you would have to flip the channels. Flip either the R, G, or B channels. This is something you can do after the fact. You can open it in Photoshop and flip the channels manually, of course. So if you see that, oh no, the bake didn't work, I have to bake again. Or you can try to go into Photoshop and flip some of the channels. Now this is a little tricky because depending on the render engine or depending on the game engine, this will vary. So it's a bit of a nightmare. Why don't they have one standard? I don't know. Would help. But anyways, let's try to just create all maps. So now you can see normal map is enabled, and down here we're now in the normal map tab, and we're looking at this. It's set to subdivision level 1. that doesn't mean, of course, that it's sampling from subdivision level 1, because that wouldn't make any sense, because we don't have, the information is on the highest subdivision level. But it means that it's optimizing the normal map to be used for a map that would be in subdivision level 1. And that's what we want. And this is useful for, like, if you have a higher resolution mesh, and then you just want the tertiary details in the normal map, then you need to set this higher so that it's actually sampling and optimizing the normal map for a higher resolution mesh. Or, yeah. Actually, it's more relevant if you're doing a bump map for, yeah. What was that? No, flip V, flip vertically, flip vertically. It just means that it flips the image vertically, literally. That's also something, of course, you could do in Photoshop. You just flip it around and save it, and then now you flipped it. But now you don't have to do that. It's just going to flip it for you. That's great. And yeah, what's that button? I don't know. Recalculate, smooth it. I don't even know what that is. Anyways, 4K. Let's try it. Create all maps, and then it's going to start trying to create the map. Let's save it here. Bust. I'm just going to call it normal, and it's saving it as a TIFF. Okay. This should be pretty quick. It's not very, yeah, so there it did it. It is very quick though. I'll give it that. But sometimes maybe it's gotten better. Let's see. So here we go, bust, normal, retop. Oh, and also the naming convention here. I'm not really sure how to set it so that it will give me exactly the names that I want. We will be a little bit more particular about that when we're exporting UDIMs, which I guess we'll do after a short break. But let's just have a look at it. And there it is. So you can see, yeah, this looks quite successful. This is right, this looks kind of like what we were looking at online. You can see this kind of pattern. It's a tangent space normal maps. And it's kind of subtle because all of these are kind of, what we did here was just kind of, I did it very quickly, just made some very subtle, small tertiary details. Okay, let's apply it, see what happens to the bust that we made. Bust, retopo UV. Okay, so this is, sometimes when you export an OBJ, you'll see that you'll get this material file. You don't really need that, just need the OBJ. But this is the OBJ, I'm going to drag that into Maya. There it is. Why is it strange? Don't know. Oh, it was in lit mode and the light is odd. Okay. So, let's make a new blend. So, same process. We have to, well, actually, we already have one here, right? So, we'll just, I guess I'll use that blend. And then we'll just go into the file node and I'll change out the normal map. Let's go to bust. So that's the normal map. Okay. There we go. And let's observe it here. Press 6. That's not looking very great, is it? Let's see. Mesh display, soften edge. Well, it's kind of working, but it's not working. Let's see. Yeah, but this is a display thing. Let's see. Let's try the legacy high quality one. So you see, it works here in the legacy high quality. So there's nothing technically wrong with the normal map. We've baked a successful normal map, and we can see these are all the tertiary details that are being displayed. And so depending on, like if you took this into Unity or Unreal or, you know, chances are it would look pretty good. But you have to try it, and you might have to flip, like I said, you might have to flip one of the channels. Unfortunately, I don't remember like for Unreal or Unity, like specifically what you would have to do if you bake it in ZBrush. But, you know, just try it. But sometimes you can see that what should appear to like bump out, sometimes it can look like it's bumping in. then okay, maybe then you try to flip the green channel. Typically, that would solve it. Okay, but let me actually. So now in viewport 2.0, that's the new viewport, and I think there's just. Oh yeah, so like I said, here I changed this, didn't I? So on the file node, change the color space from sRGB to raw. And now that should work. Yeah, so that's it. And but it's a display thing, right? It's just using the GPU to show you this. So if I press 5, that's just the shaded mode. Press 6, that's the with the normal map applied. So that's for an in-game mesh. Now this is pretty dense, probably for an in-game. Well, not necessarily. It's okay for a hero asset. And so it would be very responsive, right? Right. Ta-da! Questions? I know there's a lot of buttons to push and things, but so summarized, you have a Dynamesh, you retopologize it, you make UVs for it. In this case, I had some problems with the UV master, but I made it work. You wouldn't have to do the UVs in here. I could have taken it into Hedis or Maya or wherever you're comfortable doing UVs. In this case, to make the UV master work, it had an issue with the poly groups, it seemed. So I went into poly groups. This is also pretty important. When you don't want a whole lot of poly groups on there if you don't need it. So I just masked everything. I said group masked, and then made sure that I had only one poly group. And also I deleted the existing UVs because it seemed like it had UVs, which was disturbing the UV unwrap. And then I went to C plugin UV master unwrap, and it did it. So then I had a mesh with a new topology and new UVs, and the old, well, that didn't work either, right? But technically, what you would do then is you would place the old bust, which would be your Dynamesh bust, on top of the newly retopologized mesh with UVs. And then you select the bottom one, which is your new mesh with topology and UVs, and the old one, which is your Dynamesh with all the higher details. You click there to enable it, but you still want to be on the bottom one, and then you hit project all, and ZBrush will, project all those details onto the bottom mesh, but you need to make sure the bottom mesh obviously has enough resolution in order to, if not, there are no polys for ZBrush to displace, right? So you just have to subdivide the newly retopologized mesh, hitting Control D. What you want to be careful with when you're subdividing hitting Control D is that there is something in ZBrush called, and I've mentioned this, called dynamic subdivisions. This is more if you're working with hard surface modeling. Like if you have creasing edges and things, and then you hit dynamic subdivision, it's like hitting number 3 in Maya. So you see, but the problem is if you do that in ZBrush and you already have 1 million polys, it's going to quadruple. So, or if you have 10 million, it's going to quadruple. So that it makes it really, well, it can make ZBrush just crash. But what I'm saying is when you hit Control D, what you don't want to do is hit D. Just hit D first and then Control D, because then you're actually, you're quadrupling something, you're quadrupling, and it's just, you'll see that ZBrush just lags like crazy, and that, yeah. Then all you do is disable dynamic subdivision. But, so anyways, yeah. And then when all that was done, we went to another C plugin called Multi-Map Exporter, and we exported a normal map in tangent space, optimized for subdivision level 1. We flipped V on it. We made a 4K map, which we could do right here, and we smoothed the normals. I guess we could have also done this. We give a more accurate map. So do that. Yeah. Right. So anyways, yeah. So let's take like 10 minutes. We'll reconvene, or 5 minutes. Just, I think, yeah, just get up and get some air. Yes. Right. So once we have the normal map exported, let's bring the mesh into here. So that was bust retopo UV OBJ. Not currently working on my project, but of course you should. Right, so there's our mesh. We take a look at the UVs that we made in ZBrush. So what I'm going to try to do now is just to get a render out of here using Arnold and just applying the normal map. Okay, there's the quick UVs ZBrush did. It's all right. So let's go to the Hypershade. And I'll just delete unused nodes. It's a nice feature, just gets rid of anything that's not currently used. And then go down to Arnold in the menu here. If you can't find Arnold there, you should find it. And, well, yeah, you will find it. But it used to be the case that we have to go into the plugin manager. But now it's enabled by default. Just showing it anyways, in case some of you experience that's not there. You go M2A. That's the Arnold plugin, and it needs to be set to loaded and auto load, and that should be fine. And now Arnold should show up here. You have an Arnold menu right here. This is and Arnold will be you'll be able to render with it. But it's now default in Maya, so you should find it. So go down to Arnold, and we'll just do an AI standard. So which just to do like a simple clay render kind of a thing. We'll apply that. And let's just try to render this and see if we can get an image out. So to add some lights, we can go to the Arnold menu, and we have some lights here. So we have area light, sky dome light, different lights. Sky dome light just fills the scene with a dome, and we just fill it with light. Just try to render with that real quick. So let's see the render settings. So I'm just doing a very small little render. Hit the render button. That's it. So you can see it's very uniform light, and the material is set to white. So I think we're going to dial that down. So double click the material, just dial down the color a little bit maybe. Something like that. So to select that dome light, you can just drag the selection marquee, it will select it. We can also add another light source. Let's see if we can get more, like an area light. So maybe we have a key light up here somewhere. So for this, I can set up a renderable camera. If I want to, I can make a new camera. So under here, perspective, new. So now I'm actually observing the scene through a different camera, right? So I can set this up here. And this, I can name this my render cam. So I can set it to render with, oh, I guess that's not where I rename it. I got to do it on this tab. Or better, just in the outliner. So this is the default perspective camera, right? But currently we made a new one, so this is perspective 1. Just going to rename it. So when you start rendering, it's a nice habit just to make a render camera. Then I can go also camera settings, resolution, gate. This shows me exactly what the camera sees, right? It's a tiny little render 960 times 540. But it's nice to just do some look dev. And if I want to, I can also go hit Control A, which doesn't work here for some reason. I use that to toggle between the channel box and the attribute editor. But yeah, It's kind of annoying here because it's such a small image resolution, no, screen resolution. But let me hide some of the UI elements. See if that helps. Hide some of this. Yeah, we need that. Okay. And also I only have one monitor, so this would be a little bit more forgiving if you have a few windows open. Okay, so channel box, where did you go? Down here. Okay. All right. So if you find the channel box for the render cam, just go here and you can actually just right click and do lock selected. So now you can't move the camera. So if I try to move this camera, it's not going to work. So if you just side on a frame, just leave that camera like that, and then I can even go back to the other perspective camera. So there I see the render cam. You don't have to do this, but it's kind of a nice practice because then just make sure I hit render and I render from the render cam. So when I render, I can keep moving around, I can do changes to the scene, but I can just render from this static camera all the time. It's just nicer because it's easier to see the changes I'm making so that I'm not always changing the angle. So, attribute editor for the sky dome light. The channel box is still there. Okay, go away. Okay, now I can get it if I hit Control A. Okay, fine. So, attribute editor for the sky dome light. I'm just going to turn down the intensity. Okay, let me kill this for a minute. Let's see. Okay. I want some more interesting light setup here. So just so we have a bit more clear key light. So you can start playing around with also now with rendering a little bit, right? Because ideally, you don't have to, but you can try to present your sculpts using a bit more, a nice render with some nice lighting. And Arnold is just a really powerful render engine. So you can get some more natural looking light. So here we're working with the key light. We can add a fill light. So this would be more a traditional kind of a light approach to this. You can also experiment though with adding HDR probes. Have anyone tried HDR lighting before? No. So a lot of new information coming your way. But basically, in Arnold, we have this light dome. It just casts light into the scene. So you can see that if it doesn't have anything attached here, if it's just a white color, it's going to be very boring. It's just going to fill. You can still use it, but it's just, it just fills everything with light. You should try it. You can also do some nice things with it. But you can also attach actually an image here, which are HDR or EXR formats. I think maybe we'll have to, I can talk more in depth about HDR lighting, but essentially image-based lighting, it's just an approach to take a setting And if you probably tried like a panoramic shot on your iPhone or something, like things are getting pretty sophisticated where you can just do an easy panorama today and you can stitch it together. You probably tried that, like a 360. So you'd have to do that, but in addition, you would take like several exposures per image. So it's like you would take maybe 6 exposures. So you would get a much larger dynamic range. Because when you just take a picture, you can imagine if you take a picture of a person in front of a window, you would have to either, you always have to like find that middle point where do you want the background really blown out and overexposed, or do you want the person to be in clear. So you have to make that sacrifice. Whereas our eyes are actually there's much more fidelity. You have a much higher dynamic range. So there's much more information typically around us than what you can capture in like a low dynamic range image format. So that's why we have these high dynamic range formats. So there's much more information stored in this format. So this is a 32-bit image format. Photoshop can open these files, but it's required a lot of programming actually in order to make the 32-bit image files work in Photoshop. But if you just download these files, like an EXR file, we can have a look at it. This is nighttime desert. You can see here, this is a spherical panoramic image. So if we were to apply this to a sphere, we can look around it. And that's what you're doing, like if you try to QuickTime VR or any of these like VR experiences. That's actually not virtual reality. It's just you can't move around, but you can look around. So it's it's not really VR, but that's it. So if we were to apply this to a sphere, you can have that effect. We can actually look around and it would look as if we were standing there, more or less. Okay. And that's why we can apply this to something like a spherical light in Maya, because it's already optimized to be wrapped around a sphere. But just to show you, like there's much more information here. In the exposure, we can turn it down. So there's much more information in the brightest part, and there's also information like in the darkest areas. So it retains all this information is in here. So it's not really okay. So that's just to say that you can apply this and actually use it for lighting, and that's image-based lighting, which is probably a larger topic. But for all you need to do then, I have some of these also on the server if you want to go to and just try this. If you go to teaching, jewels, resources, there are some HDRIs in here. And here's this SIBL is a simple image-based lighting. This is just a free image library. And in here, there's all these different, okay. If you go in here and have a look, you'll find some different versions. And this has to do, depending on with render engine you're using, like Mental Ray or V-Ray or any of these other renders engines. A trick sometimes is to make a lower res version of the HDR image and blur it out, because you don't need all that information actually just to cast light. You just need a general, so you blur it out, and there's all these tricks to it. But Arnold is so powerful with this, so you don't really have to do that. Arnold really handles large files very well. So if you find some in here, you can look for the actual HDR or EXR file. So there are two formats, HDR or EXR. They're two different formats, but you can use both. You can use either. I think Arnold prefers EXR, if I'm not mistaken, but both will work. So you just look for, see there's a JPEG in here. There's also this one in HDR. But see, this is very tiny. So this is the one that's actually blurred out. That's what I'm talking about. So when it comes to rendering, there's all these tricks. All these cheats. This is not a rendering class, but it's just this is quite simple if you just want to try it. Just look for the HDR, EXR files. And then I just copied some over to the path here. So we have nighttime desert. We had a look at that. Etnies Park. Let's have a look at that in Photoshop. There we go. So there's a lot of information here. If you go to image exposure, so you see it has that information right there, but it also has all the dark in here. Like this, you wouldn't have this in a normal image. You would have to compensate. either the sky would be blown out to see this, or you'd see the sun and everything, but you would never see this, what's in here, right? So that's the whole point. So, and then in Arnold, you can just, there's a couple of ways to set up an HDR environment sphere in Arnold, but you can simply make a sky dome light. If you make a sky dome light, it just fills, like I said, it's just a huge sphere, but then you can actually attach one of these EXR HDR files directly to the color of the light. And so usually, and I don't think you'll have a problem with it, if you click here, you know, that you'll attach it. But for some reason, it's having some issues today, so we'll just do that manually again. We'll just make a file node. Oops. You can make a file node in here in the hypershade, and then turn off the filter type. And I'll grab, yeah, let's try that Etnies Park one. So if some of you are interested in like how can you go about making your own HDRs and things, we'll find an opportunity for those of you who want to try it. There's a software called PT GUI, which is great for stitching, and I think we had at least a couple licenses a while ago. But if you're using the wrong software, you know, you'll spend forever, and it's not necessary. Should always look for the right tools. Anyway, so here, I think we need to change this though to. I'm sorry, I don't remember this. This is at the raw, probably. Yeah, I'll have to look more into this. But HDR, EXR, I mean, because all these workflows differ a little bit depending on the render engine. But we'll just drag that onto the color of that light. Yep. And let's hit render. Because the intensity is too bright. I just wanted to achieve some more interest here in the render, but this is something you have to just start experimenting with. If you want to make some nice presentation renders, it can be nice to actually add an HDR and EXR environment, because you will have some more, even if you're doing a clay render, because you'll have some more variation there, and the shadow areas won't just be completely, let's see. Oh, I attached it to the area light. That's not right. Okay. Wrong light. It's not the area light. It's supposed to have it. So that can be like white. And then here we go. Sky dome light. Middle mouse button, click and drag on the color. Let's try to render. So there's all this. It's just using all of that color information from the HDR. It, you get all these kind of interesting variations. Right. So that's really that. Let's just try to apply first the normal map, and we'll see if that works in here. So all that we've done now is just we've added the sky dome light, we've attached HDR for the color of the sky dome light, and that's it. And then, okay, so, but now let's try to get the normal map that we baked out for it. So to render in Arnold, we have to flip the green channel because we baked it in ZBrush. Let's just try to bring it in here and we'll see what it does. I want to show you because you have to troubleshoot this sometimes yourself. You have to just observe and look, does it look right? So let's try just to apply it. So we'll do file node. And here, turn off the filter type. Set the color space again on the file node to raw. This is for normal maps, and then find the normal map that we did. Yeah, and I made a flip G version, but I'll show you how you can do that manually. Okay, so yeah, it recognizes it as an sRGB, so it sets it to that, but I want to switch it to raw. And then, yeah, it should work. And then just select the AI standard, the material. Yeah, this screen size is kind of not so optimal. All right, so there we go. And then we find the bump mapping. Middle mouse button, click and drag. And then the bump 2D node needs to be set not to bump, but tangent space normals. So this is what we did. So let's grab the AI standard and we'll graph the input connections. So that's all we did. So we have a file node. It has the normal map. It's set to raw and color space. I turned off the filter type, which is like just a little blur, right? Don't need that. And then it gets a bump 2D node. This needs to be set to tangent space normals, not the bump. Bump is for grayscale bump maps, but now we're using a tangent space normal map. Goes into the normal camera of the shader. So now this should work, except for the fact that the green needs to be flipped when rendering with Arnold. But let's render with it and let's see what it does. Sometimes you can also just click the mesh. Like if you have a low resolution mesh and you don't want to subdivide it, I could subdivide it, I can hit number 3 and render it in Arnold. And Arnold will recognize that you hit number 3. It will subdivide it when you render. But for this, it's pretty high def. I mean, it's pretty well defined. So I want to save some time here in the render. Maybe I can just do soften edge on the normals, right? To get rid of that faceted look. But now this also has a normal map though, but even though I could still do that, and then try to render. This is kind of low res, so we can't really see it too well. I think we'll exaggerate the lighting scenario again, but I can see that it is there. I'm just gonna exaggerate the light source so we have some more direct light. Gonna increase the intensity of the key light. Set this to 3. So we have some more key light, and then maybe we'll just dial down the dome light here a little bit. 0.4. Yeah, so you see there's something there. I want to think we'll need to render a little bit high res to see this. So this is good for look deving, like if you just want to dial in like a light scenario, and then, but then to actually see a little bit more, you obviously need to render it at a little bit higher resolution. So let me do that. So in the render settings, just go down to, yeah, just do a full HD. Hit render. If we click a 1:1, that little button there, it's going to show you the actual pixel size according to your monitor. Like it's going to show you full HD. Right now this seems too small because I'm working on a very small resolution here up there. So when I click there, it should get larger. I'm just going to wait till it's done. I'm not really sure why this is happening because the render is done. So it seems like it's still processing after the fact for quite a while. So I'm not really too sure why. And I've seen this, the latest version of Maya, like latest versions of Maya. We do have a render farm at school, which set up to render with Arnold. But to do this simple look deving, you can just render locally. But if you want to shoot out large turntable renders, if you want to be doing a little bit more, you would need to use the render farm. So get back to that. And then that will be a lot quicker, obviously. You wouldn't have to sit and wait for the render. We just send it to the farm, and then you'll get it back very quickly. But this is taking too long. Yeah. But this is kind of the nature of the beast here with the look deving and rendering, and when you're, it takes time also because we have to wait for the renders. Not so much for if you're working in game, it's a bit more instant, right? But okay, so let's try to compare this. Here we see the render is complete. So hit 1:1. These are the actual pixels. So we can start to compare that with what we're looking at in ZBrush. We can see that it's definitely not right. These little details are supposed to be bumping out, but here it's just sort of this pattern. So let's try to flip the green channel. Well, I already did it, but let me show you how to do it. So, I mean, it's very, very simple. You just open it in Photoshop. Then you go into the channels. Then I'm going to go to the green channel in this case, and then hit Control I to invert it. And then go back to the RGB. And that's it. So now that's just flip a channel. Flip one of the RGB channels. In this case, the green channel, just save this. And this would be flip G, flip green. So let me just replace. So when you're look deving and you're rendering to see that the progression, you click here to store keep image. That will just save this image in the render view. So when we make another render, we can use this bottom slider to look between and see the changes. That's actually very, very useful because it's kind of hard to see what's off, and then you make a change, and then you have to see if you're getting closer to what you want. So go to the, let's see, Hypershade. This will be a little bit easier for you on the lab because you'll have a couple of monitors. Now you sort of need that. Or a larger resolution than this. Okay. So this one, yeah, so just replace the normal map with flip G, and this is a TIFF file. And we got to remember to set this to raw. And well, let's try to render again. So this is still just using a normal map. It's not going to displace anything. Actually, it's just doing that surface detail. But in this case, what we're dealing with it are mostly surface detail. So yeah. So it might not look like the same as in ZBrush because this is a very different material. You know, we'd have to have more specular highlights, but that has to do with the material. So, but now it seems to me that definitely they're bumping out. So we're getting that. It's getting there. So let's, yeah, have to wait again. Yeah. So we baked the normal map in ZBrush, so therefore I had to flip the green channel for it to appear correctly in Arnold. Maybe that's enough for today, actually. Maybe you'll do the retopologizing, and then you will do you'll attempt to do a normal map in the lab session. I think we'll hold off with the UDIMs till tomorrow because maybe it's just too much anyways. Julian, you really want to see it now, or? Yeah, we'll do the UDIMs today. We'll get it done with. I'll do it. Okay, and we'll do it. We'll definitely need a break. Okay, but we'll extend the class today. If you don't have a problem with it, you're all fine with it. Julian's fine with it. You're fine with it. We'll extend the lecture. No, Luis, not so much. It probably take I don't know, an hour or something. No, maybe 40 minutes. We'll see. We'll take a break. We'll do it. I'll set up the UDIMs. We'll be exporting. We'll try to render a displacement map. This is not relevant, though, for game people. If you don't want to try this, I mean, it's interesting. But for games, you don't typically do multiple UDIMs, and this is what you do. You do normal maps and put it in your engine. But here we can, you see, that's the difference. So it's much easier to see this right here when I just store the previous image and I can go, oh, that's the change. Yeah, so that's pretty dramatic change, actually. Right? Yep. Huh. Questions? No. Yeah. Okay. Okay, I'll go get a refill of my coffee then, and then get re-energized. And we'll come back here at 12:30, and then we'll do displacement mapping, and we won't stretch it more than an hour, but I think I'll probably be able to do it in like 40 minutes if we don't run into the thing with this is you never know, there's so much stuff could happen, and you have to wait for the renders and export and everything. Yeah, but I'll show you the basics, like how can you approach this in a VFX render when you need more fidelity. Yeah. So we'll do that. Let's do that in 15 minutes. I'll go get some more coffee and we'll do that. Right. See you 15 minutes. And if you're not interested in the multiple UDIM displacement thing, I don't mind. This is sort of what you need. If you just want to do a normal map, that's fine. Okay. But I'll see those of you who are interested in 15 minutes. I will be recording it, so yeah. Yeah, so we got the normal map working eventually. To make this look a little bit more like to actually see the little details and things, it might help to, in the material itself, go and add some more specular values. So here under specular, just increase the weight and maybe the color of the specular. And here there's a roughness slider. So this is a PBR material, it's a physically based material. So this type of reflection is much more physically plausible than for instance like a blin, which is very simple. But so here you also have this roughness slider, which will actually sort of mimic micro grooves on the surface. So the surface is still reflective, it's just that it's more rough kind of a reflection. So we will not, since we sacrifice some parts of this course, but I think it's for the better. But we're not going to cover too much about these things, except that, obviously you have to go in here and be a little bit mindful of it if you are to do rendering with Arnold. And I'm not making anyone do it. It's if you're interested. But now there's more specular value, so we could try to kick off a render with that, and you would, yeah. But let's not. Let's get going here with. So we'll start talking about displacement maps. So unlike a normal map, displacement maps will actually displace the surface at render time. So these are very tiny details. This very. Maybe we'll add. But it doesn't matter. It's not to say that you can't use displacement maps for it. You can, of course. But maybe so that we'll see some more, let me not do that. Some more pronounced effect. Maybe we'll add something that just bumps out of the, maybe I'll just not worry too much what it looks like, just more technically. If you can, ideally, this should be done before you, yeah, okay, so yeah, this should be done before you do the retopologizing and, but let's try, I really want to have something that would bump out more. So that we can actually see a change in the contour, like that. So it would change, you can see that change in the contour. You will never be able to achieve that with a normal map because it would look like it's bumping out from when you're observing it like this in a normal map, but as soon as you go to the contour, it will be totally flat. So to achieve anything like this, you would have to opt for a displacement map. But if you're doing like a high def VFX render of a hero creature, you can just do displacement maps anyways. It doesn't matter, it will just displace everything. And Arnold is pretty powerful when it comes to displacement maps. Let me not add those, actually. I just want to make sure that this will work technically. And we can look at more, like I said, maybe we'll do some more abstract examples in the lab. So we'll just take a sphere and we'll experiment with how can we actually just try to bake a normal map, how can we bake a displacement map, and then you'll apply it to your own more creatures and things. So yeah, so then obviously we just change this to displacement. We're no longer doing a normal map. But we're going to talk about two things at once. So also for for VFX, in order to have a high enough resolution here, maybe it's not enough, and definitely this would be the case if you opt to do like a full body, like if you want to try that assignment, you'd need more than just a 4K map, probably in a high definition render. But how can we do that when everything is one mesh, right? The only way to do that is to split the UVs up into several regions. So take a look at the UV editor. So far you've been used to always having to place the UVs carefully within the 0 to 1 range. So it's still important to observe that the UVs need to be within their region. So all the UVs here are not extending the 0 to 1. But actually, the UV regions just continue. So the way we're going to do this is that we're going to be able to split this the UVs for this object into several regions. So I can do it right now if I want to just make some arbitrary cuts here. If I go edge and I just select that edge loop and just go and cut it. Now it made that cut and I can go, let me grab that shell. So just cutting this up into several regions. So obviously the point now is that I can increase the total, you know, instead of having this be the final resolution for the head, more or less, I can now increase it by a lot. So make sure that fits within 0 to 1. So I'm not scaling anything independently of anything else. I'm keeping a uniform texel density throughout the entire mesh. You could opt to make the head a little larger than the rest if you want, some more resolution in the head. That just means that you can go closer on the head in the render, right, than you can with the rest of the body. So you can make those kinds of decisions, but typically, at least you have to be very mindful that you're keeping a certain even texel density. So anyways, so I'm just trying to make some cuts here. This is typically something I would do, you know, in Hedis. I could just bring the object in there and cut it open into how many pieces I want. And where I place the seams or make the cuts, yes, there are going to be seams there, but it's actually less of an issue because, especially in this workflow, because we're not really texturing in Photoshop, you know, adding details. We're using ZBrush to do the sculpt. And then for this kind of workflow, you would then use something like, oh, there seems to be a hole in the mesh right there. Well, that's mysterious. Missing a poly. Right. So that makes me curious. Let me not spend too much time on that. But just want to see it. So press F, I can frame in on that. Yeah, so it's just, there's a hole in the mesh there. Don't know how that happened. All right, I think this will work anyways. So, where was I? What was I saying? Okay, so let me cut. Yes, I was saying if you, like in this kind of workflow, we would also use like a 3D texturing application like Mari or a Substance Painter. You can even texture in ZBrush, as we've seen. But it's a little bit limited in comparison to Substance Painter, which has become sort of a standard for texturing. So that's why seams are no longer so much of an issue. So you can actually just cut this open however you want. The thing is just to make sure that everyone fits inside these patches. So if I want, I can make a little decision here that, well, okay, I can scale this part a little bit down. That's the back of the head. I can do that because it's not gonna actually lead to the texture appearing in a strange way or anything, because the texture is just a 3D texture. It just means that there's going to be lower resolution in that area, a little bit, but not noticeable. So I'm really just cutting it up. Let's see if we can place these two on the same patch. I think I'm going to probably scale all of these a bit down, but uniformly, so but we'll leave them there. And again, yeah, so this is something I would spend time doing in Hedis. What's all this? Don't know. I mean, yeah, it takes a little bit of time to export to Hedis and things, but I probably would have been done with it already over there. It's just faster. Let me go to a wireframe, maybe that will make things smoother. Yeah, all right. I'm just gonna spread these out into various patches. There's a button here to move the used to be a button to move them precisely one unit. Yeah, they moved everything around, of course. Transform. Hmm. Move. Okay. So move precisely one. Let's try that. Yeah. So that moves it precisely one. Well, this is a nice tool actually, because now you can move it around as you want. Precisely one UDIM. So we call these patches, like if I just move it a one over, this is in a different patch, which we call UDIMs or UV regions. But UDIMs is like a naming convention that we're going to use. And it's the best one. There are some other conventions, but UDIMs seem to be winning that battle. So yeah, I'm just placing it just to see if I can get everything in there. Yeah, whatever. Let's just. Come on. Okay. I'm just gonna go like that, and then they're sort of in there within the regions. And then I'll start shuffling things. Okay, so this is too large. For the sake of time, let me just we'll go like that. So obviously, probably you just want to maintain a uniform textile density. But if you want to, there really wouldn't be too much of an issue if you decide to scale the back of the head down or something. But point is, you don't have to worry too much because the reason we're doing this is that you have a lot of space now. We can just shuffle these UDIMs around. Okay, maybe this might be many for because usually you would send this off to a farm or because the render times here obviously will increase. So maybe I shouldn't have done even this many UDIMs to render locally. Maybe it'll be okay. Let's try it. But I probably won't do 4K patches. I'll do 2K just to show you the point. But now obviously if we were doing 4K textures, just for the bust we would have 4K times 1, 2, 3, 4, 5, 6, 7. So 7 times 4,000 pixels, which means you could do a large render even for print or cinema, and it would hold up in quality. So that's why we're doing this. It's just a technical limitation, because if we could just export, a 32K map, and you can, technically you can, but it's just not optimal. You get these very, very huge files. It's difficult to manage. So it's actually better to manage these files, even though it seems a little unnecessarily complex, but it's not really. This is it. You just shuffle it into UDIM patches. So you can do maximum 10 horizontally. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you do more than 10, you have to start going up. And that has to do with the naming convention. So if we go UDIM naming convention, let's just find an image. Yeah, so this is called 1001, 1002, 1003. So the render will actually recognize this in the naming. So we're going to name these files correspondingly. So it's going to look for that name and assign it wherever it finds a corresponding patch. So that's why if we go more than 10, it would be 1011, but then that needs to be here. So we call it 1011, and you put it over here, it needs to be here. So that's it. And then you can have like 100 patches, then you have 100 times 4K for a full body, which would be a lot of resolution. But if you have a hero creature in a movie and the camera needs to go close, 100 UDIM patches is something that is done, or a lot of patches. But of course it gets complex because you get a lot of files, not just for the color, but for the color map and the specular map and all the maps, displacement maps, you know. So the file handling here becomes very important. Like you have to be, right now I'm not working very structured. I'm just throwing it on the, but you would definitely want to, did it also cut the, hang on, it should not cut the object. No, the object is whole, fine. And, but definitely work within a Maya project, obviously, becomes pretty important. So I'm just setting up a project. Seems like everything is bugging out today. So it's not letting me set a project. Great. Let me reboot. No, just open Maya again. Okay. So let me just talk about displacement maps while this is. So there are different types of displacement maps. We have grayscale maps, which is like a bump map. Well, it's technically it looks exactly like a bump map, and it is like a bump map, except a bump map technically, if you apply a normal bump map, it's just like a normal map. Like it won't actually displace the surface, but the displacement map will displace the surface. So, and you can use grayscale maps, normal grayscale maps, but they will, I am recording this. Yeah, but they're a little bit more tricky to set up. So we're going to use 32-bit EXR files, which are, there's much more data, but they're more accurate. And they're actually, well, okay, there could be a lot of issues with them as well. But once you have the correct maps exported, you don't have to worry about the scale, like to set it up the correct scale. It should work. And Arnold is actually very good at rendering a displacement. It's just the render time that's an issue, and especially now, like showing this in a. But that's why you have to be a bit patient. Like when you're doing this work, it will be very time consuming. This is not something you can hold off till you have to just get started. Because it takes a lot of time with the rendering and waiting, and so I'm not allowed to make a project. Set project, I can set a project. I need to make a project. Nope. That's really strange. Well, I guess we'll set it to another project, just so we have a project directory. Or not. We'll just stay structured. But obviously, make a project folder. But I'll just make my own folder here, which would be my textures. Or image maps, or source images, or whatever. These will be the final image maps. So when you're dealing with baking, it becomes really important that none of these UVs are outside any of the region boundaries, and also that you don't have overlapping UVs per shell. If you do, that could be one of the reasons why the baking failed. And so display, no. Where's the, nope, I want to see the colored versions. Where's that? View, here we go, shaded, okay. It's easier in the shaded mode, so you can go in and just carefully look if you have overlap. But that's really important. Really make sure that you don't have. It looks fine. Apart from some strange, that hole, I don't know how that happened. Things like that, and I would have addressed that, obviously, but for this, let's just try this. So, okay, so now this is set up. So we have 1, 2, 3, 4, 5, 6, 7 patches. So now let's try to export the 32-bit EXR from ZBrush, but we obviously need to import this mesh, which has the UVs. So we'll just export that as OBJ. So let's see. We can actually also go. If I don't want to switch the tool, like if I quickly want to import something, I can also use the subtool master and then multi-append, and that's going to open the file browser, and then I can select it. So now that appended it. So we have bus retopo UDIMs. Now obviously I need to bake down the details, and ideally would have had some more interesting details. We don't really can try to. I'm not going to spend time with this, but just make something that would be a little bit more evident. Whatever. Very quick. And then go to the bottom one, which we now need to subdivide. So Control D, Control D, Control D. Now we have 700,000, which is the same as this one. And then just have the one visible that you're sampling from, and have the one selected that you're sampling to. And then we go again, project all. There we go. And just turn off that one. Yeah, more or less successful. Some weird artifacts. We can just smooth that out. So this happens sometimes when you project. You have to go over and you just double check, see if you have some artifacts. But now, if I hit Shift D to go down, that's our lowest level. D, I can go up. So now obviously we want to export this and bake this information down onto this version's UVs, which are in UDIMs. So it's the same process. We'll use the multi-map exporter. We're doing a displacement map. So we'll go down to the displacement map settings. And again, this means which level is the displacement map optimized for. So you can just leave this at level 1 because you probably want it to be able to displace a mesh that looks like your level 1. And displacement, no. Yeah, this would be more accurate. We're doing a 32-bit EXR file. And then we can turn down the mid range. This is the sub-pixel accuracy. It will try to do an even better quality, but it will take longer I don't think you need it. Yeah, that should be it. So this will create 3 identical channels, which we don't really need. Like, it's just because the image format has RGB, well, and alpha, it has, but essentially it asks, do you want to save this information into the RG and B channels? But you don't really have to do that. It's just going to make it the file larger. So by default, it's going to store the information in the red channel. And then that should be it. So if you're using a 16-bit and a grayscale, uh, not a 32-bit, it would be a little bit more tricky because then you have to take the scale into consideration, everything. Here you don't really need to do that. So I'm setting the mid to 0, 32-bit EXR, adaptive mode. Should be fine. So now, one more thing though, because we want to make sure the UDIMs are exported. So it's going to recognize that these are UDIMs. It's going to export it as UDIMs. But we can also go to file names. And this has to do with the naming convention. So currently it's set to another UV tile format. But we want to click here until we find UDIM. And then so I haven't figured out how to make it export the files, naming them precisely the way I want. There's always going to be some strange names there. You can use a bulk renaming app after the fact, to rename all of them. But the important thing is in the naming convention, there needs to be a dot before the UDIM number. So you'll have blah, 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 file name, da, 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 call it whatever you want. Then dot number, the UDIM number, which is like 1001, 1002, 1003. And then dot format, the EXR format. So that's the only thing I'm going to do here is just going to make sure that this would say, whatever. Yeah, so displacement map, but then dot. And I think that should do it. Hit OK. And then create all maps. Now that's going to take a little while, but let's just do 1K for this. It's just going to simplify things. But you get the idea. The whole point of going through this is that we can have high resolution. So obviously, we would have exported 4K maps, but just for the sake of time here. So create all maps, and then obviously you need to be really particular about your path and everything. And here I made this. Yeah, so this is what I'm talking about. I can probably try to make this naming the way I want, but let's see what happens. Okay, there it goes. So this is the baking, and this is just an automated process. So as long as your mesh is technically correct, your UVs are technically correct, that's all you can do. And then you gotta cross your fingers and just hope that the bake works. And sometimes it doesn't, so you might have to try to bake again. But there you see it's naming it, so 1003, so now it's halfway. So this is pretty forgiving. It's not that high res or high poly, and also we're just doing 1K maps. But this process would take a lot longer if you have a lot of detail, which is also part of the point of doing this. So you have a lot of fidelity, you have a lot of detail, and you want to make sure it looks great. So this takes time, all these things. But you probably want to do this. Make sure you just try it once at a lower resolution to see if it works, just so you get the idea. So now it's doing 1006. We had 7. There's one more. So currently it's storing 32-bit images, so there's a lot of information. And EXR is just a file format. Okay, so that was very quick. And then go and take a look. So these are the UDIMs. So there's a dot So that's really all it is. You know, there's no magic here. It's just we're looking at 7 image files and they're named accordingly. So let's try to open that just to have a look at it. So what we should see if this worked, probably a red. Yeah, this is kind of, it's hard to see, but there's more information here. Remember, this is a 32-bit image, so there could be more information here that you're not seeing. So that's it. And it looks red just because, like I said, it stores the information in the red channel. See, these are empty. Okay. And then, okay. Now, let's try to make sense of how to connect these. There is a manual way to do it, but there's also an automatic way, which is preferable. We can use in Arnold, there's a UDIM token or something we just type in there instead of the number, and it's going to read it at render time. But this is where ideally, you know, this should be placed in the source image directory in your Maya project. Everything needs to be very, very, very organized, obviously. So, but I do have them in, you know, one thing you need to do is to set the direct path. You don't want the path to be relative. So what I'm going to do is I'm going to try to find my hypershade. And then where are all my materials? Okay, it's very slow today. I don't know what's happening. Maya is not doing great. Could be some server issue or something. Maybe, who knows. Yeah, so, yeah, anyways. We can just make a new material now. Let's make another one. We'll go to, come on. Again, you'll have a lot easier time with this in the lab when you have another monitor. Or even just like a higher resolution. That's the problem here. Okay, anyways. So, let's make, oh, my workspace went away. Oh no. Windows. How do I get my workspace back? I don't know. Browser. Okay, that one. I want to. Okay, great. Let's make a new Arnold AI standard. So what you're seeing here, these are, okay, so if you select a material and click this button, we'll actually show you both the input and the output connections. So you see a material is actually connected to this guy, the shading group. So we'll come back to this, but that also comes into play here. Because this is where we're gonna attach the displacement shader. Let's make a file node. Oh, gosh. Okay, and we need a displacement node. It also comes with this shading group. Doesn't matter which one you use. Delete that one. This obviously then goes into, whoops, let's see. Yeah, so out displacement into displacement shader. So now that this displacement node is just called displacement, we plug it into the displacement shader of the shading group, which is also attached, the surface shader is this material that we made. And then we need to find the file, the displacement map. It's in, yep, where I put it, which was in image maps. So here what we can do, you just select the first one, open, and then you need to just double check if the path here is absolute. What that means is if you go to the front, yeah, so here you see, here you can see it says D drive, da, 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 da. This is an absolute path, like it tells you specifically where the file is. If it, relative path would have been this, like if this were missing, it is images, it would be like wherever this Maya project exists, look for the file. But if you don't see the drive, and you got to be careful also when you do like map network drive, you don't want to do that. Well, you can do that, but you don't want to use that as the absolute path. Okay, so you know, in Windows you can map a network drive, and then that mapped network will have this. It will assign a letter to it, but that's not the actual absolute path of the server. If you're rendering from the server, which you probably a lot of you will do, this would be the absolute path. You would have to go in here and copy this path. So if I didn't see this path right now, here, this is the direct path. If I didn't see all of this here, I would go like this. I would select this, Control C to copy it, and I would just copy it in here. That's what you need to do. You just need to make absolutely sure that the path is absolute. And then you carefully go in here and just replace this, and you type udim in brackets. So bracket, udim, shift to end bracket, and these need to be lowercase. And that's just that little token. This is going to tell Arnold to replace this with numbers, and it's looking for 1001, 1002, 1003, 1004, da, da, da. And just assigning them to the different udim patches. And this, again, probably, I'm saying probably because this is kind of a new, but I think I set this to raw. And it also has this built-in UV tiling mode. We don't need to use that because we're doing this. That should be it. So now we're doing that, and then we could take out color, right? But we actually our information is in the red channel. So we're going to go here and just click that little plus sign where it says out color R. So this is where our information is. So we're dragging that into displacement. All right. So that now we've done that. That's going in here. This is going to. So in Arnold, though, we can click on the object itself. And you'll find in the attribute editor, there's an Arnold tab. And this is where you have more controls. Or actually, you have to go in here also. So here you can set the type of subdivision. So this is literally like if you had, okay, so we can actually go and see in ZBrush we had, because it's the same thing that happens technically, or the subdivisions are precisely the same. We had 4 divisions. So that would be technically the same if we do 4 subdivisions here, so iterations. So if we set this to Catmull Clark, Cat Clark type subdivision. I think we set this to edge length. That will, now it's just going to run through and it's going to subdivide it to this level, which is, or actually this level, which is all that we need because we don't have any more in ZBrush. If you had subdivided your mesh to 8, you go up to 8. So, big disclaimer, this might not work. We might have to troubleshoot, you know, who knows. Maybe the bake didn't work, maybe our UVs, maybe something's off. You just have to try rendering. And that's always the scary moment because you'll see if all of this worked. But double checking, it seems like, you know, we did our best here. Everything is set up correctly. And that's all you can do. So a lot of this will be troubleshooting. You just have to embrace embrace the fact that strange things will happen. You have to try to figure out, you know, what went wrong. Because there's so many pieces to the puzzle. There's so many Yeah. I'm just saying, don't expect everything here to just work, because chances are you might have to troubleshoot quite a bit. Okay, so let me save the scene because we did a lot of changes, and let's do it here. So also we really want to ideally work in a Maya project, all of that. But let's try to render. So just do, and we'll use our render cam. And we wait. Okay, that did not do it. Maybe I haven't assigned the material, have I? That's probably it. Yeah, so sometimes it's also having issues with reading this UDIM patch. Even though you set it to, it's a little, yeah. Okay, but this is the AI standard. This one? No, not that one. That one. Retop or render. No, I did assign it. Darn it. Julian, what issues were you having with your subdivision? Yeah, but you don't have to, in the 32-bit EXRs, you don't have to play with the scale. Yeah. It should, but the UDIMPAT token should work. Might have to set up, a project, but shouldn't have to. Right. Let's see. There's the file node. No, that's not it. This is actually not the right one. I'm looking at. No, no, no. Okay, so good. Which one is it then? That one? No. What? Which one did I just set up? Is it flip G? This is the normal map. So where did, what, what? Okay, this is going into, oh, it seems like it's not currently attached to anything. Okay. It must be. AI standard 1. It's that one. Oh, I guess, okay, so it's not showing up in the, okay, well, okay, but it is that one. AI standard 1. Okay, great. let's try to render again. It didn't show me the input connections for the material because it's not the material that has the input connections, it's actually the shading group. Yay. So it worked. Good. It's just, there's all these things that, can be confusing and you don't know precisely what went wrong. But in this case, I just had forgotten to assign the material, and then I hit render. But that's quick to do. You know, you might do that, and then you think something is wrong. So, anyways, so if you had more exaggerated details here, you would see that it's actually displacing the surface. You know, so it's different from the normal map. But then we can also obviously still play around, do whatever we want to the material. So in this, let's try to do a final render, then we'll just do a little bit more specular so we can see more clearly those little bumps and things. And maybe we'll make them a color a little darker, the diffuse. And just do a render. So, and the same process, obviously, you'd need to repeat for all maps. So your color map or all the maps, you need to attach in the same way using the UDIM token. Yeah, so it's funky material, very reflective, but it's doing its job. So that's that. That's UDIMs and things. So you follow that step, those steps, and it should work, you know. But yeah. So unless you have any final questions, I think we'll do more of an abstract if you want to follow along, and we'll try in the lab. We'll just do an abstract example. So we'll take a sphere or something and just add something, and then we'll try to bake a normal map so that all of you try baking, and then it's easier to grasp the concept. And then we'll try the same thing, but export like a multi-UDIM 32-bit EXR, and so that you just follow along in the lab session. It's just much easier to do an abstract example, and then you can apply it to your own scenes. Because you're adding just exponential levels of troubleshooting when it's more complex scene, right? Yeah, but I think that's probably one of the main challenges. There's so many factors that could, you know, that's why we always stress, you know, you have technically correct meshes, technically correct UVs, and then you have to. And this is why, because when you get to this stage and you start baking, the baking itself will not work if there's something wrong. And also the displacement maps and things like that could be off. Yeah. But anyways, so I'll see you at 4, I think it was, when the lab is available. So what we did today is pretty much ran through a lot. So I know it probably, you know, it's too much to take in, but I think if we do that little what I'm saying in the lab, you'll be fine. Sort of grasping the main concepts, and then obviously you have to keep experimenting with this. But then tomorrow, I think we'll just meet then in the lab. So we'll get started today, and then you can also get started. No, this is not what I'm looking for. I'm looking for but it was 4 o'clock, right? So at 4 o'clock tomorrow, we'll meet in the lab. So you'll get started also today, probably retopologizing after we have a look at sort of the abstract example. Okay, so I'll see you over there after the siesta.